So this is topic 2. We did topic 2 last lesson. So it's about descriptive statistics. So can you still remember what descriptive statistics is? It's basically the process of you doing something to your data, trying to describe your data. The data come from the sample. Okay, so from there you can actually find out some characteristics about your data, and you can actually make a conclusion or estimation about the population, right? So the easiest one is you find the average of the sample, and you use that average of the sample. You try to estimate the average of the whole population. Yeah, so this is descriptive statistics. And in this topic, we went through quite a number of statistics. Yeah, so all these numbers are actually calculated from the sample. So all these are called statistics. So the first outcome here is we look at something which are in a center. Okay, in the center, mean, median, mode. The second outcome, we talk about something which something to do with the range. Yeah, the range, the spread, the variability of a set of data. So you have interquartile range as well. You have variance and you have standard deviation. The third one is we combine the first item, which is the mean, and the second item, which is the standard deviation, and introduce a rule to you, which is empirical rule. All right. So the parameter belongs to the population. Just remember, statistics belongs to the sample. Okay, so how do you actually calculate the mean? We just need to use a formula, and actually without the formula you can calculate it, but you just need to get used to this formula because you need all these symbols later on. Right, so all the x's are all the data points you have. The n is the sample. Okay, the sample that you have, the sample size. If you have 10 values, then n is 10. Then x bar stands for the sample mean. Is the average, x bar. Remember the name, yeah? For population, we call that mu. Okay, you just need to know mu in this formula. Okay, median, we have two ways to find out. One way is we just use the original traditional way, cancel, and find the number right in the middle of the data set, which are already sorted from the smallest to the highest number. Then the other method is we use a formula called the median index. Okay, there's a I. And when you use the I, there is a rule behind this I. If you got an I, which is not a round number, you just need to round up to the next number. Okay, the next round number. If it's a round number already, whole number, then you just need to take this I that you have gotten and the next I that you're going to the next I that you have. Okay, so you've got a second. If I is second, then you need to get the third as well, and you find the average of these two numbers. Yep. Right. So the next one is the mode. Mode is the number that most frequently occur in your data set. It may not be number, it can be just words. Alright, so small, medium, large. There are so many small, there are how many medium, how many large. So which size is actually in the middle, we call that median. But which size occurs the most number of times, we call that mode. Come to numbers, we may have a set of numbers with no mode. We can have a set of numbers with only one mode or two modes or even many modes, more than two. Right, so what is this? This is called model class. The class with the highest frequency is called the model class. We have lost the original data. We can't see this anymore once it's done in this way. So we have to rely on the frequency to tell us which class has the highest frequency. Okay? For this particular slide, what you need to take note of is mean is sensitive to extreme values, median is not. Okay, that's the most important thing. So when you have a data set where there is no extreme values, then mean is good one to use. But if there are extreme values, then you may want to choose a median as the center. To explain this, where you have three types of graphs, without drawing the graphs, you know what is a shape, yeah, by just um, analyzing the two figure here, mean and median. So if mean is bigger than the median, then you expect that mean has been, there are some bigger values in the data set that drag the mean towards the higher side. If mean is smaller, that means there are very small values in the data set that has dragged mean towards the smaller number. But if these two numbers are the same, then you can see that the shape of the graph is almost symmetrical or bell shape. Okay, this is bell shape. Quartiles, remember quar means 4. So we're going to split the data set into 4 sections. Smallest is minimum, the maximum is the highest, and we have 4 equal sections. Each section is 25%. So at this point, it's called first quartile. We call that 25th percentile. At this point, which is the median, we call that second quartile or the middle quartile or 50th percentile. And the third one as 75th percentile. How do you make use of this formula? You are going to use a rule, same as what you have done for median. Okay. Right. Then we move on to the variation, which tells us about the spread of the data set. We do have range, which you have seen in our first lesson. And range actually covers the smaller number, the smallest number and the biggest number. So it can give you a very huge range if there are extreme values. So how to handle this situation? We're going to use an interquartile range. Interquartile range will only cover Q1 to Q3. So it disregard the minimum, disregard the maximum. So you will get a more accurate spread, which gives you the 50% range in the middle. Population variance and standard deviation. What you need to know about this slide is what is a symbol for variance. The symbol for variance is sigma square. Okay, sigma. Sigma square is a variance. Standard deviation is just sigma. So hope you still remember the relationship between variance and standard deviation. Variance is 25, standard deviation is just the square root of 25 and you get a 5. Okay, so the other way around will be true. If standard deviation is 4, then the variance will be the square of the standard deviation. For square, you get 16. Sample, variance and standard deviation. Just now, we know population variance is sigma square. Population standard deviation is just sigma. So for sample version, if you remember what I said earlier, in sample version of the formula, you don't see any more Greek letters. So the standard deviation will be denoted by just S. S stands for standard, the S here, standard deviation. Okay, S stands for standard deviation. So if you square the S, it will become variance. So between the two formula we are going to use this to do a hand calculation. Yeah, use a shortcut formula. Once you get this S square, which is a variance, you just need to square root to get S, which is the standard deviation. Alright, so this is just an illustration. The last thing that we have in this topic is we combine the mean and standard deviation together and applied it in this rule. Let's say you have a bell-shaped curve, very nice, the bell-shaped curve here. The center will always be the mean, which is the mu. Okay, and for any bell-shaped curve, there are three important sections on the right hand side and three important sections on the left hand side. The fourth one is very small, so not so significant. Yeah, the more important ones are the three on the right and the left. For each of these sections, the distance is 1 standard deviation. 1. So if standard deviation is 10, then every of these distance is 10, 10, 10. Okay? Right, so this is what you have. Then the rule says if you are going to look at the area from the center, 1 standard deviation to the left up to here, and up to 1 standard deviation to the right up to here. So the whole green patch here made up of 68% of the entire area below this curve. Okay, this is the magic number that you need to remember. And 95% covers from 2 standard deviation up to 2 standard deviation. Okay, so this is how you write the mean plus 1 standard deviation minus 1 standard deviation is 68. Mean plus 2 standard deviation minus 2 standard deviation is 95. Okay, and the third magic number is 99.7. You will know how to find this out in topic 5. So at this moment, just memorize these three figures. Right, so that's all for the last topic. Right, so I noted to you that we won't be going through the exercises in tutorials for this particular topic, right? Because they are quite straightforward, so I will not go through with you. The answers, the final answers are all given to you, so you can double check. What we have done for this particular one is we have gone through the lecture exercise. I show you how to do it, right? So you have the mean, you have the median, two ways of doing it. You have the mode, then you have the range, and you have variance, and you have standard deviation. Then the part C is you're going to find the IQR, but you need to know what is Q1, you need to know what is Q3. Okay, right. So that's all. Now I'm going to move on to topic 3. Topic 3 is about probability. Just to bring you back to this again. Remember when you have two circles, when you bring out, this is a sample, right? So this is a population. And you have a sample. Why you take sample? Because population is usually too huge for us to handle. So we just randomly pick some elements in the population and we call that sample. So earlier I say maybe there are 30,000 here, but you only take 30 here. Right. So once you have the 30, you can actually find out the average. Yeah, I'm just still using the same example we have. Let's say the average now, you know what is the symbol for average is X bar. X bar you calculate from these 30 numbers, let's say it's $3.50. The bubble tea, yeah, the price of one bubble tea, regular bubble tea for these 30 stores is $3.50. What are you going to do with it? You are going to do a estimation. Okay, you see there, okay, then the average, which is the mu for the population, will be somewhere around $3.50. Right. So what are you doing here? You try to estimate, right? You try to estimate. Okay. So you see that when you do an estimation, this is equal sign. When you do an estimation, is this exactly 350 cents? We know it cannot be. Most of the time it won't. Why? Because we only rely on 30, but there are 30,000 here. It can only give you an idea about this, okay? An idea about the whole thing, but it may not be exactly $3.50, right? So if it's not exactly $3.50, that means that is a plus and minus. Yeah, maybe it's around there. Right, so once we say that maybe is this number a little bit bigger or a little bit smaller, maybe from $3 to $4. So if we have that, then we introduce something called we are not sure, uncertainty. So if you have something which is called uncertainty, you are just you are just doing an estimation, but with some possible error, right? So you cannot be 100% sure that this is $3.50. Maybe it is 90% sure that it's $3.50, but you have 10% not sure. It may be $4 or it may be $3. Okay, right. So when this uncertainty comes in, then we have to dive into another concept in statistics, which we call that probability. Okay, so this topic will be touching something called probability. Now, I understand that some students don't like probability, but don't worry, we are not going to advance probability. We are just doing something basic probability that so that you can continue on to the next two topics, which is also probability. Okay. Right. So remember, whenever you make estimation like this, you cannot be 100% sure. There will be some uncertainty. So you need to tie in the probability here. What is the probability that the average for the population is $3.50? Maybe you say, okay, 90%. Okay, so that's how you use the probability. So now let's go into the probability. Let's say you don't like the word probability because it makes you nervous. What are the other words that you can use to replace probability? You can use the word chance. Okay. You can use the word possibility. Or you can use the word likelihood. Yep. The chance of this happening, the chance that there will be a rain tonight is probably 30%. The possibility that there will be a rain tonight is 30%. The likelihood that there will be a rain tonight is 30%. So you can use the word, any of these words. They mean the same thing, right? So the next thing that you need to understand is, this one we say 30%, right? So what is the smallest number that I can assign to a chance? Something that cannot happen. What would be the chance? What's the chance that after you finish the class at 3 o'clock, you can go out and play with snow? Is it possible? Not possible. So what will be the figure that you're going to attach for this chance? It will be 0%. Okay, so it will be 0%. Cannot be, something cannot happen, right? So what about something that surely happen? You usually tell your friends, you say, I'm 100% chance and this is no, I tell you that this will happen, right? So the maximum that you have is 100% chance. So 30% chance, if you convert to decimal, how much is it? 30 over 100, you get 0.3. So this is in percentage. If I were to put in decimal, there will be 0 up to 100 chance will be 100 over 100, right? So it will be 1. So this is impossible. This side is sure happen. That side is impossible. Okay, got it? Right. So it tells you something that when you solve any probability questions, if your answer go out from this range, then your answer is definitely wrong. You must get an answer which is between 0 and 1. In other words, you must have the answer at 0 point something. Right, so that means or you put 0 to 100%, 30%, 65%, 41%, whatever. So 0 0.41, 0 0.3, 0 0.9, 0 0.98, it cannot be 1.1. Yeah, so take note of that. Okay, now we move on to the next word. Experiment. I'm sure you still can recall the experiment you did in your secondary school. What is objective? What is your objective of doing certain experiment? For fun? No, right? You do the experiment with an objective, with a purpose to find out a result. Correct? You want to know if I do this, what will happen next? So you want to know the result. So same thing in probability, we also have experiment that we call that probability experiment. And this probability experiment is not so complicated like the scientific experiment in the lab. What you can do is you just need to ask around maybe 20 of your friends. You're asking them the same question. Do you like this brand? Do you like this brand? Do you like this brand? Okay, you're asking a question. Very simple question. You show them a brand. Do you like this brand? For example, you show them a watch, okay, and with a brand. Then you ask your friend, do you like this brand of watch? Okay, then one say yes, the other say no, yes, no, yes, no. So what is the outcome that you can have? You either get yes or you get no, right? But they should not be telling you yes, then they don't say no, 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 right? So that must be only one outcome. Clear? So experiment is a process that produces a single outcome. You only have one outcome. You either say yes or you say no. But before they answer you, you don't know whether they want to say yes or no. So whose result cannot be predicted with certainty. You cannot be very sure that this person will like this brand or that person don't like this brand. You don't have any certainty. Okay, that is called the probability experiment. Now you noted the word here, outcome. Outcome means result. It's the same word, but in a probability, most of the time we just use the word result. Right. The last one, what is a sample space? The definition says the collection of all possible outcomes that can result from a selection, a decision, or an experiment. Let me show you here. What is sample space? When you toss a coin, you toss a die. This is a die, right? So you toss it. How many sides you have? It can give you 1 to 2 and 3 and 4 and 5 and 6. Right. Can you get nothing? Cannot. Can you get more than 6? Also cannot. So what can be the result when you toss a coin, toss a die? You can get these figures. So these figures, this is the outcome, will be called sample space because it is all possible outcomes that can result from an experiment. Okay, so when you toss a die, this will be all the possible outcome you can get. Now we look at the example 2. When you are playing a card, how many cards do you have? 52 cards. Any of these 52 cards identical, exactly the same? None. So all 52 cards are different. So if we were to pick any one of them, all different, right? So you have all 52 different cards. Yeah, so you have 52 possible outcomes if you were to just pick up one card. Example 3, If you have 2 coins, when you toss these 2 coins, what can you get? You may end up with both getting head or both getting tail, right? Or one tail, one head, or one tail, one head, something like that. So this is what you get. So you have all this. Head, 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 tail, head, tail, tail. Can you get something else? No more. So these are all the possible outcomes when you toss 2 coins. Next example. When you're answering a true and false question, what else can you answer? You have to answer whether it's true or you answer whether it's false. There's no third option for you to answer. There is no blank or there's no yes, no. Yeah, there's only true or false. Okay, so this page is illustrating to you the sample space concept. Now, before I go on to the next one, let's say you're answering this true and false question. What's the chance you answer it correctly? If the answer is true, what's the chance you answer correctly? Then you have to look at how many possible answers can I have? I only have 2. So I either get this or this. So the chance of me getting this is just 1 over 2. Okay, the chance of this is correct is 1 over 2. Half, half. Right. So the reason why we need to know sample space is we need to know overall all possible outcomes. There are how many? So if there are 2, that means each one has same equal chance. 1 over 2, 1 over 2. So now we look at something more complicated. Now you're going to toss 2 dice, 1 and 2. So you toss 2 dice. If this one is showing 1, this one can be showing 1, can be showing 2, can be showing 3, 4, 5, 6, right? Then if this one is showing 3, the second one can show 1 or 2 or 3 or 4 or 5 or 6 also. So you end up with a table looks like this, right? So die number 1, if the first number is 1, what can be the second die show you? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5 or 6. If the second die, first die shows you a 2, if this one shows you a 2, then what can this shows you? It can show you again 1 or 2 or 3 or 4 or 5 or 6. Okay, so you end up with how many possible outcomes? 6 times 6, you end up with 36 outcomes. Okay, so what is the outcome? What is the chance that when you toss 2 dice, you will get a sum of 2? You get a total of 2. So for example, what's the chance you get this one showing 1 and this one also showing 1? Only 1. 1 and 1 out of 36. Okay, 1 out of 36. Clear? So you see that you need to know the total, all the possible outcomes, then only you can find out because you need to put it in the denominator. Right, sometimes if you need another level, so for example, I'm going to toss these dice for 3 times, or I have a coins and I'm going to toss a coin for 3 times. So I'm not able to write that down in this table form, right? It will be quite complicated, quite confusing if I were to list down things like that. So I will seek for another method which will make things clearer, which we call that tree diagram, or in long words will be probability tree diagram, right? So for example, you are going to ask students whether they like statistics, and you're going to ask just 3 students. What can be the first one answering you? If you ask if I were to ask any of you, do you like statistics? What can be your answer? Your answer can be no or yes. If you ask the second student, what can be the answer? Also no or yes. The third one also no or yes. So I'm going to combine this into this. The first student, when I ask the first student, do you like statistics? No one, yes. But I don't know, before I ask anyone, I don't know the person will say yes or no. I know they will either say yes or that someone will say yes or no, right? Okay, let's say the person say no. The first person say no. First student say no. What can the second student say? The second student also can say yes or no, right? Okay. If the second student say yes, can be the third student saying still yes and no. Okay. So you see that every branch will be branched out again and again and again like this. Right. I only have 3 students. If I have 4 students, then I branch out again. Right. So now you can combine all of them and find out what can be the outcome of this experiment. When you ask 3 students whether they like statistics, you will get all these outcome. Okay, the first one say no, the second one say no, the third one say no. No, no, no. Or you can have the first one say no, the second one say no, the third one say yes. Then you have no, no, yes. Okay, or no, yes, no. No, yes, yes. Okay, so you see that you can list this down very clearly and easily. If you were to just put down on the table without drawing this diagram, you may be quite confused with, okay, is it yes or no? Is yes, no, 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 yes, no, yes. We may miss out something. Yeah, but if you were to use a tree diagram to present this, then it's very clearly there will be 8 outcomes here. So if I ask you one question, what's the chance that all of the students say no? Will be 1 out of 1, 2, 3, 4, 5, 6, 7, 8, right? Out of 8. Okay, so everyone is actually 1 of 8. So the chance of getting all yes is also 1 out of 8. Now, how about 2 of the students say no? What's the chance that 2 of the students say no? So you have to look at, there are 2 no's inside. 2 no's, okay? 2 no, okay? This one cannot. 2 no, okay? Some more? No more? No more. Right, how many of them? Total will be 3 out of 8. 1, 2, 3. Okay, 3 out of 8. You will have 3 out of 8 chance that when you ask 3 students whether they like statistics and 2 of them say no, is 3 out of 8. Okay? So this is another example for this tree diagram showing you the gender of children. You have a sample space for the gender of 3 children in a family. Boy, girl. This is a first child. This is a second child. And you have the third child. So you have the outcome. What can be the combination of boys and girls in a family of 3 children? This can be the outcome. Boy, boy, boy. Boy, boy, girl, and so forth. Yeah, again, there are 8 of them. What's the chance you get 1 girl in a family? 1 girl, 1 girl, 1 girl, 1 girl. Okay, 3 out of the 8. Okay, you have a chance of 3 out of 8 to get 1 girl in a family if the family has 3 children. Are you to draw this out? Tree diagram when you toss 2 dice. Okay, how many sides on die? So you have 2 dice, right? Okay, you're throwing these 2 dice. So what can be your first outcome? there are 6 sides on the die. So you have 6 sides. So if the first dice is showing you a 1, what can be the possible outcome for die number 2? You will have 2. Sorry, you have 6 again. So you have 6 and 6 and 6 and 6 and 6 and 6. So what's the total number of outcomes you have? 36. Right, you saw that just now when we used the table to show it, right? Now you can also use the tree diagram to show it. So some students find that this is easier to see. Some students find that the table is easier to see. So it's quite personal. Now, after you have drawn this, it's up to you what you want to know. Let's say I want to know the sum. What is the sum of these two dice? So for example, number 1 and 1 will give you a 2. Sum of 2. Okay, sum of 2. If you have, let's say, 1 and 6, it give you a sum of 7. Clear? Okay. Since this is a brand new concept again, which is in probability, so you expect to see some new terms again. Yeah, these new terms probably is nothing new to you in normal English, but when it's used in statistics, in probability, the meaning is slightly different. Yeah. So here we have something called event of interest. So let's say you have an experiment. An experiment, you're going to toss 2 coins. Okay, you're going to toss 2 coins. What can be the results for tossing 1 coin? You get either a head or a tail. Right. But when you toss 2 coins, what would you get? You will get head, tail, head, or tail. You get 4 different outcomes. So the event is, what is your interest? Event of interest, that means you as the person who run the experiment, what is your interest? Maybe you say, okay, I'm interested in getting both tails. Okay, then you'll be interested in getting both tails. So this is the event. Okay, it's called, this is one of the event. What's the probability of getting this event? The chance of getting this event is 1 out of the 4. Okay, or you say, okay, I'm going to look at those events that you get at least 1 hit. So how many of these will have at least 1 hit? 2 hits is also considered, 1 hit also considered, is at 3. So what's the chance of getting this event? Okay, event, back to here. Event is just a collection of experimental outcomes. So you choose, what do you want? Yeah, these are all called event. Now we're going to look at how many types of events do we have? We have events that cannot overlap. In other words, they are mutually exclusive. For example, you're at home now listening to me. Can you be at the mall shopping at the same time? No way. Yeah, you can split into 2, right? So the event that you're at home and the event that you're shopping at the mall, these 2 events are called mutually exclusive events. Okay, so let's look at the definition here. Mutually exclusive events are events where the occurrence of one event precludes the occurrence of the other. That means the next one cannot happen. If they cannot happen at the same time, they have no outcomes in common. For example, the product can only be good or defective. You cannot say this product is good and defective at the same time. There's no, like you are at home and you are at the mall at the same time, which is impossible, right? So events that you cannot have happen at the same time, then we call that mutually exclusive events. The other event is called independent events. So two events are independent if the occurrence of one event in no way influence the possibility of occurrence of the other event. Right. So for example, you hold a coin in one hand. You hold another die on the other hand. When you toss this coin, what would be your next toss on the die? Will the die, the result of what you get from the die, depends on what you get from the coin? It won't, right? So if you toss a coin on the right hand, what would you get from the die on the other hand? Anything, right? So they are not dependent on each other, so we call that independent events. How about dependent events? It's just the opposite of what we have just seen. Two events are dependent if the occurrence of one event affects the probability of the other event occurring. It affects, it influences, it's affected. Okay, there are so many words, right? Impact, influence, affected. Okay, so whether or not a working adult take umbrella to work is influenced by the forecast reported the day before. So not only the working adult. So for example, yourself, if you are the one who don't really like to bring umbrella with you, and you always rely on the news the day before and tell you whether today there will be rain or no rain. So let's say yesterday the weather forecast reports that today there will be thunderstorms. So you want to bring your umbrella out when you go out. You have a very high chance of bringing your umbrella if this is what you heard last night. Okay? But if last night the weather forecast say today will be a total sunny day, shiny, yeah, very sunny, nice, windy day. So you won't bother to bring out your umbrella because of that weather forecast. So whether or not you bring out your umbrella is actually influenced by the weather forecast reported the day before. Okay, so when you have such events, event that you bring out your umbrella, and the event that you no rain or not, these two events, they are dependent. Okay, now we talk about a lot about this basic probability concept. Now we're going to look at how people assign probability. How people assign probability. You probably heard people say that no, there are 50% chance of raining tonight, or my friend has 70% chance of winning that the match, the football match later. Where do you get these numbers? 50% chance, 70% chance. Where did you get all this? There are actually three types of ways you actually assign probability. Okay, so for example, the first one is called classical, second one is called relative frequency. Relative frequency should not be something new to you at this moment. What is relative frequency? You try to find a percentage, right? A proportion when you are doing up this frequency distribution. And the last one is called subjective. Before we go on, there is a notation here. This P is called probability. And you have a bracket. This bracket, inside there is something happening. Okay, so for example, I may write the probability that I get a 4 when I toss a die. Okay, the probability I get a 4 when I toss a die is 1 out of 6. So this is just a way you put it in notation. So in statistics, like what I've told earlier, we are not going to write long sentences. We are going to write everything in symbols. Yeah, the probability of getting a 4 when you toss a die is 1 over 6. So what are you going to put inside here is up to you. The P must be the capital P. The bracket must be there. There should not be any equal sign in between here. Okay, there must be empty here. It's immediately there. But what are you going to write inside is optional. You can say getting a 4 or so for example, you just get a 4 when tossing a die, or you just write get a 4. That's it. So as long as it's complete and you know what you are doing, that's fine. So let's look at the first probability assessment. Classical probability assessment. The method is based on the ratio of the number of ways. This is called ratio. Something divided by something is called ratio. What is the ratio? The number of ways an outcome or event of interest can happen to the number of the ways an outcome or event can occur when the individual outcome are equally likely. Okay, the number of ways something can happen out of the total number of ways of the possible outcomes. Right, so for example, if you are tossed a die, the chance of you getting a 4 from a die when you toss it is the total number of possible outcomes when you toss a die will be 6. The number of ways this can happen, this event can happen, getting a 4. How many ways 4 can happen? Only one out of the 6. Okay, so you don't need to memorize this formula. It's just common sense. Okay, this is what I explained the first one. Probability of guessing MCQ with 4 choices correct. Right, so what's the chance if, let's say, E2 denotes guessing MCQ with 4 choices correct? What does it mean by 4 choices correct? The 4 choices. That means your MCQ will have question. So for example, this question asks you something and they ask you A, B, C, D. Okay, so you have A, B, C, D to choose from. What's the chance you choose the right answer? One of the 4, right? So the chance of you choosing the right answer, guess the MCQ with 4 choices correctly, is 1 out of the 4. Maybe this is a correct answer, so it's just 1 out of the 4. Probability of getting 2 girls in a family of 3 children, right? So this is what we have seen, right? How many of them have 2 girls? 2 girls, 2G, 2G. Okay, this one has 2G, this one has 2G, this one has 2G, this one 3, the one already. So how many? 1, 2, 3. So it will be 3 out of the total of 8. That is called classical probability. So classical probability, you don't need to run an experiment. You just need to know the logic. If I toss a coin, there are 2, so each side is half-half. If I toss a die, there are 6 sides, so every side is 1 over 6. Okay, so the probability seems to be fixed. You don't need any experiment to show you to find out what would be the percentage or what would be the possibility of happening. When we come to something not so not in this nature, then we have to find out some data. The method defines probability as a number of times an event occurs divided by the total number of times an experiment is performed in a large number of trials. Okay, what is it? So lengthy, right? So never mind. Just have a look at this. This is what you see on your first lesson. The table is actually recording how many people do not read newspaper in a week, reading newspaper one of the weeks, reading newspaper two of the days in a week, 3 days in a week, and so forth, right? So what's the chance if you were to pick anybody here or anybody in the same area? What's the chance you get someone who don't read newspaper at all? Then you have to get it from here. According to the data collected, 44 out of 200 do not read newspaper at all. Okay, 44 for 200 do not read newspaper at all. So the chance is 22% chance. So what's the chance that you pick someone who do not read newspaper at all? The chance is 22% chance. Right. So this type of probability assigning probability is called relative frequency probability assessment. Right. So when you need to know something and you cannot know without doing any experiment, and you can collect data to get your answer, that probability is called relative frequency probability. Sometimes you don't know what is the probability, but at the same time you also cannot collect data. So if you cannot collect data, then you are going to guess a number for the probability. For example, you're going to feel based on your gut feel. I think it is so. I feel that it should be that, right? The method defines probability of an event as reflecting a decision maker's state of mind regarding the chances that a particular event will occur. The probability value is based on the educated guess. Okay, no guess. You guess it. You estimate it. You use your opinion. You use something not exactly correct information to try to figure out a probability figure. Right? It represents a person's belief. I think my friend will win the match 70% of the time. Okay, so this is what you believe your friend. But another friend will say, I don't think so. I think uh, your friend only have 50% chance of winning. So subjective probability is very subjective as well. From person to person, it may not be the same. So you can only use it as a approximate guide to the future. Weather forecast, sporting events, who will win the match, the football match, who will be the champion, you will know until it finish, yeah. And it's hard for you to collect data as well. The other one is election of president, yeah, of the person who are going to be the president of the student club. So all these you would know exactly what's the chance of happening, okay? But you just guess it. Clear? Right. So I'll just go back a bit. These are the three different ways people assign probability. So sometimes they need the data to show you. Sometimes they don't need the data to show you. You need a data to tell. This one is you don't need because things are fixed. What's the chance you toss a die and you get a 4? Okay, fixed already. You don't need to run experiment to get the answer. And sometimes you will let an answer, but you cannot take the data. There's no way for you to collect data. This is called subjective probability. Are you able to get data? Who will win the election next Monday? No one will say, yeah. No one will tell you the truth. So you want to collect data, you would like to know, also you can't. Right. So you end up giving something very subjective, saying that I think this guy have only 40% chance of winning the election. Then another person say, no, he has 80% chance of winning the election. Yeah, so very subjective. Okay, so this is how you assign probability. Okay, now I'm going to go into some rules. Some rules. How do you know what to do with probability questions? There are certain rules that you just need to follow, right? So they are quite fixed. The first rule says when you calculate any probability, the answer must be always 0 to 1. This is what I told you at the very first slide, right? So you see all the numbers here. Are they between 0 and 1? 5 over 16, 0 point something. 4 over 16, 0 point something. So they are all fractions. right? So the last one is 16 over 16 will be 1. Okay, so from there you can actually find out what's the chance, what's the probability you get probability you get 2 transactions done, 5 out of 16. So you get 31.25% chance. Next, you notice that when you add up all this, which I showed you just now, you get 16 over 16. You must get a 1. Okay, when you total up the probabilities of all your outcomes, all your results, you must have exactly 1, not more, not less. If you get less, that means maybe you left out one of the possible outcomes. If you get more, of course, cannot be more. Whether you get less or more, just double check whether your calculation is correct. Okay, you must get a 1. Let me ask you, what's the chance of getting 1 transaction done? What's the chance of getting 1 transaction done? 1 transaction done will be 4 out of 16. It will be 25% chance. Then I ask you one question. What's the chance of not getting 1 transaction done? What's the chance of not getting 1 transaction done? If not 1, it can be any others, right? So how about adding the rest? This one, this one, this one, this one. When you add the rest, you'll be equal to 1 minus of this, right? Okay. So when you have multiple outcomes and you want to find what's the probability of getting, for example, you have this. If event E denotes getting 1 of 4 transactions, what's the probability of you getting 1 of 4 transactions? 1 transaction is this much. 4 transaction is this much. What's the probability of getting this or this? The or in probability you must add. You just need to add the 2 together, and that will be the probability of 1 or 4 transactions. Okay, so that is one of the rules. Whenever you see it or, please add. This is the one I illustrated to you. Yeah. What's the chance of getting a 1? 0.25. 4 over 16. What's the chance of not getting a 1? Not getting a 1 means getting the rest, but not 4, not 1. Okay, so you get 5 plus 5 plus 2, 1 plus 1. So you get 12. So how you get 12? 12 is just 16 minus of 4, right? So it's just 1 minus of 0.25. You get the rest easily rather than this plus this plus this plus this. This is called complement. Right. So the complement of an event E is a collection of all possible outcomes not in event E. Right. So let me show you this. You roll a die and you get the 6. What's the chance you get a 6? You roll a die and you get a 6. So there are 6 sides on a die. The chance of you getting a 6 is 1 over 6. Right. So what's the chance of you not getting a 6? Getting a 6 is 1 over 6. Not getting a 6 is how much? The rest, correct? How many more sides? 5 sides. So not getting a 6 will be 5 over 6. Right? So that shows you this. The probability of getting a 6, okay, not getting a 6, okay, not 6, equals to 1 minus of probability of getting a 6. So not getting 6 is 1 minus 1 over 6. So you get 5 over 6. This is called complement. The event of getting a 6 and the event of not getting a 6, they are complement events. You select a letter of the alphabet. We have 26 alphabet altogether, 26 letters in the alphabet. And getting a vowel. What's vowel? A, E, I, O, U. So, out of the total of 26 letters in English, what's the complement of this? What will be the balance? You get a consonant. Consonant means not A, E, I, O, U. Okay, so this is A, E, I, O, U. Then this one will start from, the first one will be B, C, D, F, G, H, and so forth. So how many more to go? 21 altogether. How you get 21? 26, take away the 5. You toss 2 coins, both showing same side. Same side means either H, H, or tail, tail. So what will be the balance? Will be head, tail, or tail, head. So this will be 2 out of 4. This is also 2 out of 4. This happens to be the same. You select a day of the week and getting a day that begins with a T. So which day begins with T? You get Tuesday and you get Thursday. Okay, so will be 2 out of the 7 days. So what's the balance? You should get 5 left out of the 7 days. So this is called complement rule. The event complement of an event. So this event is a complement of this event. This event also complement to this event. They are mutually mutual complement of each. Example of complement again. A survey found that 40% of the people in the city listen to pop music. If a person is selected at random, what is the probability that the person does not listen to pop music? Listen is 40. So does not listen, how much left? There will be another 60%, right? So it's just 100%. 1 means 100%, yeah? So if you couldn't see what is it like that, minus of 40%. You get 60%. Okay, so let's look at this probability rules. We are going to combine all these rules and see what we can figure out. In a sample of 50 people, 21 had type O blood, 22 had type A blood, 5 type B, 2 AB. So it will be good if we can just put down everything in a table form. It's so much clearer. A person's type A. Okay, what's the probability that you pick up someone who has type A blood? So how many A you have? A, 22 out of 50. Okay, 22 out of 50. So you just say that probably you're getting an A, or you can put type A, you can put type A blood, something like that. Next, what's the probability a person has type A or type B? What do you notice? You're going to? Yeah, remember this. Whenever you have an or, you have to add. So what do you have in A? What do you have in AB? So we're going to do with just add add them together, right? 22 over 50 plus 2 over 50, you get 24 over 50, and you get 0.48. Straightforward. Let's go to the next question. Not B. Not B. Just cancel out B. Not B and not AB. Yeah, not B or AB. So you cancel AB as well. Then what is left? You only left with A or O. So not B, not AB is the same as A or O. Correct? It's the same. So you add the A with the O, and that will be the answer. Does not have A. Does not have. That means you don't want this. Does not have. So what will be the balance? The balance will be the rest, right? So you can actually add them. 21 plus 7 will give you 28. Okay, so you have two ways of solving it. One is you use the complete rule, which goes this way. The chance of not getting A will be just 100% minus all the chance of getting A, which is 22 here. Or the other way is not getting A, that means B or A, B or O. So you're going to add these three together. 5 over 50 plus 2 over 50 plus 21 over 50. So how much did you get? 21 plus 7 is 28. Which is 0.56 also. So you have two ways of working it. Okay, right. So at the moment, I'll just stop here for a while. You just take a break, then we come back.